Hello everyone. In this video, we will see C++ references, okay? So creating references, a reference variable is an alias for an existing variable, right? It is created using the ampersand operator. String food equals pizza, food variable string ampersand meal equals food, right? If you see here, now you can use either food or meal to refer the same value. So string food equals pizza, string ampersand meal equals food, right? So now you can use both of them for the pizza, right? So you see count cout food gives us pizza, and cout meal gives us pizza too, right? Okay, both food and meal refer to the same memory location. Changing one affects the other, right? Uh, it, they use the same memory location. Updating two references. If you change the value of a reference variable, the original variable also change, and vice versa, because they both refer to the same memory location. So string food equals pizza and string ampersand meal equals food, right? So if you see here, uh, food is pizza and string meal ampersand food, ampersand meal equals food. And if you change the meal equals burger, then if you see out food and see out meal, they will give the output same burger, right? Okay. Drag and drop the correct variable name, so assigning through the reference updates the original. String city equals Paris, string ampersand destination equals city, right? uh, okay. And uh, okay, drag and drop the correct variable name to assign through the reference updates the original. So if you go to destination, what is a reference variable in C++? A reference to an existing variable, a copy of a variable that stores a constant, a pointer to a variable. A reference to an existing variable, and then create a reference variable named meal, which should be a reference to the food variable. Create a reference variable named meal, which should be reference to the food variable. String food equals pizza, string ampersand meal equals food. And then what will be the output of this code? Food equals pizza ampersand, and this would be, output would be pizza, right? Okay. Memory address, C++ memory address. A memory address in the example from the previous page, and ampersand operator was used to create a reference variable, but it can also be used to get the memory address of a variable, which is the location of where the variable is stored on the computer. Okay. But it can also be used to get the memory address of a variable, which is the location of where the variable is stored on the computer. When a variable is created in C++, a memory address is assigned to the variable, and when we assign a value to the variable, it is stored in the memory address. To access it, use the ampersand operator, and the result will represent where the variable is stored. Okay, string food equals pizza, and cout ampersand food. Okay, so memory address of the food will be shown here, right? This is the address of the food variable. Okay, note the memory address is in hexadecimal form. Note that you may not get the same result in your program. And why is it useful to know the memory address? Reference and pointers, which you will learn about in the next chapter, are important in C++, because they give you the ability to manipulate the data in the computer's memory, which can reduce the code and improve the performance. These two features are the things that make C++ stand out from the other programming languages like Python and Java. Okay, exercise: drag and drop the correct operator to print the memory address of x. Integer x equals 5, C out, print memory address, right? So if we provide ampersand here, what does the ampersand operator return when used with a variable? The value of the variable, the memory address of the variable type. So the memory address of a variable is displayed in the hexadecimal form. True. And then get the memory address of the food variable ampersand food. Okay, what is useful to know the memory address of a variable? What is useful to know the memory address of a variable? To print variable values, to perform arithmetic operations, to to manipulate data directly in memory. Maybe this one. Okay, and then we have C++ pointers. Creating pointers. You learned from the previous chapter that we can get the memory address of a variable by using the ampersand operator. Okay, string food equals pizza, cout food and ampersand food. So you will see the pizza and the address, right? Okay, a pointer, however, is a variable that stores the memory address as its value. A pointer, however, is a variable that stores the memory address as its value. A pointer variable points to a data type like int or string of the same type and is created with ampersand operator. The address of the variable you are working with the address of the variable you are working with is assigned to the pointer. Okay, so string food equals pizza, string pointer equals ampersand food, right? um, a food variable of type string. Okay, string food equals pizza, string pointer equals ampersand food. So this pointer is it's storing the address of this food, right? So if you see out food, then you will see pizza, and if you see out ampersand food, you will see the address of it. Okay, if you see out pointer, let's see the difference, right? If you see, this food is giving us the pizza, and this ampersand food is giving us the address. And as this pointer is also storing the value of the address of this food variable, so doing cout pointer gives us the same address, right? Example explained. Okay, create a pointer variable with the name ptr that points to a string variable by using the asterisk sign. Note that the type of the pointer has to match the type of the variable you are working with. Use the ampersand operator to store the memory address of the variable called food and assign it to the pointer. Now, pointer holds the value of food's memory address. If there are three ways to declare pointer variables, but the first way is preferred. String asterisk my string, string asterisk my string. So these are the three ways to store this declare pointers, right? Now dereferencing, get memory address and value. In the example from the previous page, we use the pointer variable to get the memory address of a variable, right? Used together with the ampersand reference operator. However, you can also use the pointer to get the value of the variable by using the asterisk operator. Okay, so string food equals pizza and pointer equals ampersand food. Okay, so pointer is holding the address of this food variable. If you see out pointer, you will get the address, right? And if you dereference it, okay, asterisk pointer, you will get the pizza again. This is the thing. Okay, so cout pointer is giving us the address, and if you dereference it, cout pointer, you're having the pizza, right? Okay, note that the asterisk sign can be confusing here, as it does two different things in our code. Note that the asterisk sign can be confusing here, as it does two different things in our code. When used in the declaration, string pointer, it creates a pointer variable. When not used in declaration, it acts as a dereference operator, right? Okay, so when you declare this, this is used in declaration is a pointer variable, but when you used in declaration, um, it acts as a dereferencing operator. So this is giving us the pizza here, right? String food burger str. Okay, drag and drop the correct expression to change the value of food through its pointer. Okay, so string food equals burger, str pointer ampersand food, and if you want to, so if you do it, okay. Next, what does the following code output? String food equals burger, string pointer ampersand food. What does the following code output? So string food equals burger. Okay, pointer ampersand food. So it's okay. Food's address is being okay. Ampersand. So burger is the output. And then which symbol is used to dereferencing in C++? This is dereferencing. This one. Okay. Fill in the blanks to dereference pointer. Integer numbers equals to 10. PTR, and this should be uh, fill in the blanks to dereference pointer. Okay, modify pointers, right? You can also change the pointer's value, but note that this will also change the value of the original variable. So string food pizza pointer is having the address of food. So cout food, cout so when you cout food, it will print pizza and output the memory address of food, right? So cout ampersand food, it will give the address of the food, and if you cout pointer, this will give us pizza, right? Because it is dereferencing the value, right? So change the value of the pointers. If you pointer ptr hamburger, then this will change the value of the point value pizza, and new value is hamburger, right? If you dereference this one now, that you will get that hamburger, but and if you see out the food, so food is also will be changed, because pointer is having the address of food, right? So if you change any of them, another one will be changed, right? If you see here, if you if you think some if you take some time to think it, you will get what I mean, right? So things are complicated and easy at the same time. Just we just need to be attentive to the details, right? Memory management is the process of controlling how much memory your program uses. Memory management is the process of controlling how much memory your program uses and how it is used. This includes creating, using, and releasing memory when it's no longer needed, right? So memory in C++. When you create a variable in C++, the compiler automatically reserves space in memory for it. For example, integer my number equals 10. The line above tells the program, I need space to store an integer. C++ handles this memory automatically, so in this case, you don't have to worry about managing memory. Get memory size. You can check how much memory a variable type uses with the size of operator. Include iostream using namespace std. Okay, integer my int, float my float, double my character. See out size of my int 4 bytes, my float 4 bytes, floats also 4 bytes, my double 8 bytes, and size of my character is 1 byte, right? So double is 8 bytes, float is 4 bytes, integer 4 bytes. Okay. Size of my int integer 4, float also 4, double 8. Okay. Knowing the size of types helps you write more efficient code, especially in larger programs. Knowing the size of types helps you write more efficient code, especially in larger programs. Do you have to manage memory yourself? Sometimes yes, and sometimes no. For normal variables like integer x equals 10, C++ takes care of the memory for you. For normal variables like integer x equals 10, C++ takes care of the memory for you. But when you want to create memory manually while the program is running, for example, based on user input, you need to manage it yourself and clean it up when you are done. Um, okay. If a program uses too much memory or forgets to clean up memory it no longer needs, it can lead to slow performance or even crashes. That's why understanding memory is important. It gives you more control and helps avoid common bugs. What's next? In C++, you can use pointers to access and change memory directly. This is powerful but also risky. If you use a pointer the wrong way, you could accidentally change or damage other parts of your program's memory. In the next chapter, we will learn how to create memory manually using pointers with the new keyword and how to free it using delete, right? Okay. So now we need to do these exercises in C++. When you create a variable like integer x equals 10, who handles the memory allocation? The compiler automatically, maybe the operating system. Okay. What is the output of the following code? Double my double, size of my double, so it should be 8. True or false? If your program uses too much memory or forgets to clean up unused memory, it can lead to slow performance or even crashes. If your program uses too much memory or forgets to clean up unused memory, it can lead to slow performance or even crashes. Drag and drop the correct keyword to allocate memory for an integer. Uh, Drop the correct keyword, integer, to allocate memory. Okay, so it should be malloc. Sorry, allocate memory for an integer. Okay, so let's new and delete. Let's see this one. The new keyword lets you manage memory yourself. In the example below, we create memory space for an integer using new. In the example below, we create a memory space for an integer using new, store the value 35 in it, and print it using a pointer. So integer pointer is new in it, new integer. Okay, ptr pointer 35 count pointer, right? So new integer 35.35, right? So new int creates memory space for one integer. Pointer store the address of that space. Okay, so this is dereferencing operator 35 stores the number 35, count pointer points the value. So we used new to create memory and pointer to access it. The delete keyword, when you create something with new, it's your job to remove it when you are done. To do that, use delete. Okay, so delete, example, delete pointer new int pointer 35. Okay, pointer delete pointer. Okay, free the memory. So uh, we use a free function in C, but here we use delete, right? Details C++, I am done with this memory. You can clean it up now. What happens if you forget delete? If you forget to delete memory, your program will still run, but it may use more and more memory over time. This is called a memory leak, and it can slow down or crash your program over time. Using new and delete with arrays, you can also use the new keyword to create dynamic arrays. Note, for arrays, use new and delete. For single variables, use new and delete, right? For arrays, use new and delete, okay, with third bracket, and for single variables, use new and delete. Dynamic arrays are also are useful when you don't know the size of the array in advance, like when the size depends on user input or other values that are not known as the start of the program. For example, imagine you run a hotel. Since you don't know how many guests will arrive, you ask the user for the number and create the many rooms. That many rooms want to store each guest's name. Okay, so integer number guests, how many guests? Okay, see number guests. Okay, so If number gets equal less than or equal to 0, say out number of guests must be at least 1. Okay, return 0. Create memory space for up to 10 guests. String pointer guests, new string, num guests, right? Ignore the leftover new line character after reading num guests. Okay, see in ignore. Okay, enter guest's name. Enter name for guests I plus 1, get lines cin guest I. Okay, read the full name including spaces. Okay, I need to, we will need to, uh, clearly understand all of them, right? Okay, so this is the last thing we need to understand here, so we will spend some time here, right? New string num guests. So this is creating a new string and num guests. Okay, then ignore the leftover new line character after reading num guest. So here, whatever number you provide, let's say you provided 3, right? So I would be less than 3, and each time a name for the guest will be asked. Okay, I plus 1, guest line seen guest I. See out, guest checked in, guest I, delete guest, return 0, clean up memory. I hope you understand this, right? How many guests? Maybe 3. Enter a name for guest 1. Guest checked in Sadhguru Mandrasa, right? So thank you for watching. If you want, you can visualize this code, okay, step by step. You can run this thing, yeah. Then you will feel this, right?